Niels,
Timmer,
I hear you're an expert on machine learning and interactive systems.
I'm not.
That's the perfect mindset, I guess, to talk about machine learning for interactive systems then.
Yeah, I guess so. The interesting thing is that I'm not an expert, but I think there are no experts, and that's really surprising. I mean, you also did that, right? You also did this. We did that together. We did this machine learning stuff. So you published about it. You must be an expert.
Right. The thing is, half of the time I have no idea what I'm doing, but it is kind of expected these days to have at least one or two of these papers, IOI, Chi related, where you show that you can use it as a method to actually do something. And then sometimes people mistake it as, oh, you're an expert in it, so therefore you know how to advance the field of machine learning or AI, which certainly is not the case quite. We're more like on the application side of things and try to figure out how to make use of the tools that ML people provide to us.
Yeah, that's probably true. But I think that what we still do is we innovate or we provide new methods in our domain. So I think it's like if you look at the machine learning stuff and applying that, that's not really hard, right? I mean, depending on what you want to apply, but I mean, as a computer scientist, you can do that. But then I think it's not sufficient to use what machine learning people provide to us. So I think that if you would just do that, then we do a lot of mistakes because the methods don't really work for what we want to do with them.
It has become kind of like an import thing, right? Where you used to think as a programmer, oh, I can just import this math library or this graphics library, and then I use it. And now we have machine learning where we can just use that as a component in our applications, which I think has led to a lot of that usage spreading in applications. So I was wondering, how does machine learning then and HCI come together?
Well, I think on one hand, what we can do in human-computer interaction, if you want to use machine learning, we can basically replace probably all functions where we don't really know why they work or how they work. Things like transfer functions, you move the mouse and then a pointer moves. Where does this function comes from? We don't know. Someone invented that. We don't know if it's good or if there are better ones, and we can replace all these functions by data-driven algorithms. So I think that is one. But I think that's maybe, I mean, and I think there's a lot of these problems that can be like solved or improved using machine learning, but I think the more interesting things would be different. The more interesting things is where we learn why people are interacting with the system. And that's not necessarily like just these functions, where we have adaptive systems and then the system adapts to people. Not necessarily in ways that people notice that the system adapts. I think there are also examples for that, where we could use things like you have a keyboard and then you want your keyboard on a smartphone. So you want your keyboard to adapt to yourself. Right?
What kind of adaptations is that? You mentioned keyboard. What kind of adaptations can you make using that?
I mean, there are traditionally two different models that in smartphones, keyboards. One is a language model, one is the touch model, and I think that basically the same thing people already use machine learning for that. And
what do you improve about the application there? What do you improve about the keyboard there?
You enable people to make less errors because you make better predictions. I mean, with old school language models, or like back in the days, there were models that were just words. So you know this is a list of possible words in English language, and then if someone typed something differently, then you would just replace one word by the other. And now we have more sophisticated models, and now you can do better predictions, and now you have a better idea about what people want to type, and so they type more often the correct word if they use current days keyboards. And obviously you can improve that.
That's already being used?
I hope so. I mean, there are research papers that do that.
Okay. And what about like my iPhone keyboard or Android keyboard? Does that use any of that?
I would assume, I mean, they use these language models, they use touch models, and I would assume that nowadays they use that in a data-driven way. I mean, the language model certainly is data-driven, and as it is Google, I would strongly assume that they also have machine learning in the touch model, and probably a combination of both.
Okay. So they predict my next emoji.
They predict your next emoji, yeah. Probably more on an individual character level. I mean, but you see that you type a word, and then like after you typed it, the word gets corrected. And how does it work? It's machine learning. I mean, most probably, I don't know how Google that actually managed to do it.
Okay. Are there any other applications that you could think of? Mobile, stationary. What's hot right now? Where should we focus our research efforts on?
I think what's interesting are the things you are doing, or you at least were interested in a while ago, where you look at people and you detect their emotional state, or if they're stressed, or if they're bored, and all these things. And what I would find interesting, and there's not that much work about it, to keep people in the flow. So you have something like reinforcement learning or some other learning techniques where people do something, you determine the state, and then you have an algorithm, and the algorithm tries to optimize the state in a way. I mean, the question is, who defines the goal, right? Is it the user? And the user says, oh yeah, I want to be happy all the time, and then the system tries to optimize for that. That could be something. I think that's interesting, and I think the bits are there. So we have emotion detection for different, right? We can detect if someone is bored, or someone is stressed, or someone's happy to a certain degree. And I think we also have, from other fields, algorithms to keep people, well, typically not people, but to keep processes in a certain state. I think combining these things, I think that would be interesting. I don't know if there's work, I think, from MIT, they did something in that direction, but I think without machine learning. But I think that would be interesting.
Became skeptical. So there was almost an explosion at Inwood probably 5 years ago about this, using X to detect Y, and X was often either phone sensors or environmental sensors. And so there are papers there, as you said, about emotions, depression, anxiety, suicidal tendencies, and so on. And it's really escalated down that road. And I was wondering, doesn't that, like, detecting the one thing exclude the other thing? Like, if my phone detects all of these things, what does it really pick up on? Because it seems like we can detect anything from accelerometer and location and application usage. Can we actually have multiple models running and then make an intelligent guess about all these different stages? Let's say happiness, tendency to become anxious, or stressed or nervous and such? Or are these contradicting findings?
I think at one point you want to have one model that detects all these different states, or I mean, that's what people do or you probably want to have a model which in theory is able to check all these states, but you want to be able to extend that. So you would probably want to do something like transfer learning if you're interested in yet another state, but I would guess. But I think you want to have models that covers all different states, or like everything in one application you're interested in.
Okay. So one model find them all and internally to predict them.
Yeah, and that could also improve the accuracy. And I think you really need one model, because it could be that otherwise emotional states become a completely strange meaning. I mean, maybe I'm super stressed, but I'm also super happy. But that's then completely different than being super stressed and being super unhappy, right? So you have to know both, because otherwise just knowing, oh, you're stressed doesn't make much sense. So I think you need the individual like signals, they're fine, but I think to really understand what's going on, you need more than just knowing, oh, you're stressed. Because I mean,
Right.
there are different types of stress, and just knowing, oh yeah, stress, it doesn't really help.
How does that work? If I wanted to create an algorithm or a model that predicts, let's say, if my user is hungry, how would I go about as a researcher building such a model?
I don't know. I mean, you probably did more on that domain than I did, right? I would probably equip people with my sensor, whatever sensor that is, a phone, and then I would do experience sampling. I would ask the person every hour, how hungry are you? So like randomly distributed across the day, 12 times, how hungry are you? And then I could collect a lot of data from a lot of people, and then I would predict their hungriness level.
So there's this notion of we need some kind of ground truth. It's like we need to know the person is hungry right now, and then we need to know all these data that we can collect unobtrusively or continuously alongside with that, so that we can compare these situations. What are these situations? How do they look like when you're hungry, and how do they look like when you're not hungry?
I mean, you could do other things. You could also, I mean, if you, I don't know about the process of getting hungry too much, but you can also use other types of sensors, right? You can probably, blood sugar level is probably a good predictor for being hungry. I don't know, I could imagine that. There might be other things. So you could try to have an objective way to figure out how hungry people are.
So that would be another way of collecting ground truth. Because you mentioned experience sampling, right, which is quite subjective. Basically asking people, how hungry are you right now from a scale to 1 to 10 might be very different depending on, for example, if I had a huge meal yesterday and I can't, let's say I'm completely sick of chicken, right? I'm really hungry, but I'm sick of chicken. So if you ask me right now, while I am in the aisle of the chicken meat in the supermarket, how hungry are you? I would probably not say that I'm really hungry, even though I might be hungry. So a subjective confound. No, okay. Let's rephrase this in a sense that subjective ground truth can be convoluted, right? Do I know from what does it mean from 1 to 10 being hungry? Like is 5? Yeah. Is 1? I'm completely bloated.
No, I think you don't predict. If you build such an algorithm, I mean, you have to be aware of what you're predicting. So you don't predict if a person is hungry. You predict if a person would rate the hungry level to a certain level. So the algorithm cannot figure out if you're hungry or not, but we assume if you say you're hungry, you're actually hungry. But we only predict the degree with which you would state you're hungry, not if you're really hungry. So I think that's the difference, and for being hungry or not, it's probably not so important, I would guess, but maybe it is for other things.
Right.
People looked into binge drinking. Can I predict binge drinking episodes? And I think if you look into similar things, then predicting if people are currently binge drinking, I mean, it's different from predicting if people would say they're currently binge drinking. I could imagine.
Yeah. So subjectivity is not objective. Do we? I guess we could then. You said the glucose level might be a more objective way of doing that. Maybe we could use phone camera to actually see when people ingest something, or a sensor on your neck that detects a swallowing event.
Yeah, but then, I mean, if you really want to, I don't know why, but if you want to detect if a person is hungry, right, then you don't want to detect if a person is eating or is saying, I'm hungry, but you actually want to determine if the person is hungry, right? So
you assume that hunger precedes an eating episode?
yeah, I think there's a assumption behind all this, right? You can be subjective, but it has limitations. You can measure if someone is eating and then have the assumption, yeah, you're eating, so you must have been hungry beforehand. And that's certainly not true all the time, just as the subjective rating is not true all the time. So I think,
that can be a serious problem in other type of scenarios when we think about how well does the ground truth actually reflect the state that I'm trying to predict.
Yeah, so I think there's a difference. Often there's a difference between the thing that you would like to predict and the thing you actually can predict. And I think that's different compared to most of the other things that are done with machine learning. If you look at computer vision and you just want to build a classifier, is there a plane in the image? Well, there's a plane in the image or not, right? And then you only have these edge cases where you are not sure, is this still a plane or not? But then you have to have definitions for what is a plane. And I think that the problem is much easier because it's much more objective. And you can actually predict the things you want to predict. And the ground truth reflects what you want to predict. And I think for HCI, that's often not the case.
Right.
Yeah.
And so, okay, let's say we do have a way now of collecting the ground truth. We choose a couple of sensors that, in an optimal case, people wear with them anyways, like their watch sensors or their phone sensors or maybe their glasses, and then we correlate basically these episodes of hungriness with the data, right? And so we build these models. And then they run in the background and kind of like predict these states. And then what? What can we do with it? These type of predictions on an application level.
I think that depends on what you want to do with that, right? I think you did this work with Martin on boredom detection. And I think that I really like that because there are two different things you can do with that, or I mean, you came up with two different things you can do with that. One is you detect if a person is bored, and then the next step is you give them micro-learning tasks. So something that's very nice, right? You support people in their learning activities, and then they learn the language. That's fantastic. And then you can also like push ads to them. And I think those things are examples of stuff that you can do with it.
Right. Yeah, the learning part was interesting in the sense that if we
it didn't work.
Aren't you a co-author on that second follow-up paper?
Yeah, and I think my conclusion from that paper is it didn't work.
Yeah, so basically we tried to, so we had an algorithm that detected whether people were doodling around with their phones in idle situations. And yeah, the study with Martin Pilot was about, can we then push content like reading BuzzFeed articles to that user, and that worked quite well. And then we said, okay, if people are bored, maybe that correlates, a state of boredom correlates with a willingness to study vocabulary, which it mostly didn't. So we had to, it was interesting though, we had to retrain that algorithm, right? And to adjust it to the situation. So we had a new ground truth of when do people actually engage with vocabulary, foreign language vocabulary. And these situations were inherently different than board situations. So there was a second model basically that needed to be built in order to detect those opportune moments for injecting learning content.
So is it then, I mean, the first model probably it was only good for BuzzFeed articles, and the second model was only good for microlearning. So labeling one of these models was like a broader concept, like, oh, you're boredom, right? Maybe that was the mistake. Maybe only works for, I want to support this specific activity and can create a model for it, and then it works. Or do you think labeling things with, like having the broader model and then using that for all kinds of things? Do you think that would work?
Well, that was the idea. Was maybe these situations are similar enough so that we can use the same model, but they're not. And I think that's one assumption that people often make when we say, oh, we can detect whether people are happy. Clearly, when they're happy, they want to look at X, Y, Z, or they want to engage with their friends, right? But actually, other studies found, oh, we actually reach out to our friends when we're really sad, right? Because we need emotional support. So that's an inherently different state people are in. So I think, the conclusions that we can make from a particular or from a machine learning model that has been tested in a particular situations cannot easily be generalized. And I think that's a big insight also from the AI community, right? Where we have like very specific AIs, artificial intelligence applications that can solve one thing and really, really good, like cats versus dogs, right? Image recognition. And only now we're seeing things like deep learning or neural networks that can actually pick up on new inputs and new outputs and extend their horizon in a sense where they become more a general artificial intelligence. And I'm really excited to see how that plays out for, let's say, an assistant on a phone, right, that learns about the user at the moment that user has purchased the phone, starts up the phone and starts using the apps and installing their office basically, and then having that assistant kind of learn from the interaction and then from the maybe of the moods and from the type of people that I converse with in order to build different types of prediction for different types of states and help me throughout the day with managing those states.
Yeah, I think I would have two comments on that. One is, I think if we want to do that, we have to go beyond what's, I mean, the only thing that's used in HCI is just supervised learning, and I think that's something HCI people should probably reflect on and go beyond that. And I think that would be needed for things as you mentioned. And that would be exciting, but I think the tools that we apply at the moment are too limited, and we would have to look at actual current state of the art of machine learning. And we don't do that. I think what I find fascinating is that if you have an Alexa, so I have an Amazon Alexa, I have multiple ones, and I find it interesting that it's so terrible. It's like, it can't do anything. I can set a timer, I can play music. It doesn't really work for music that well. I don't know, and it's super useless, and it's super bad. And I wonder, what is Amazon doing? I talk with people, and they say, well, they just collect data. So if it happens that like these speech interfaces really become commonplace, they have the data.
Yeah.
But
okay.
Why is that so bad? Why is Amazon's Alexa so terrible? I mean, or maybe it works for you.
You have one in your home.
Yet
you seem to have one in your home, as you just put a timer for this recording.
Yeah, I have multiple ones. I probably have 20 in my flat, yeah. But that is because I did a study.
The other 19 you hope will pick up on it?
No, most of them are still in boxes, but I have one in my living room. I have one in every room at the moment.
Put each
but
one.
That's just because I did a study on it, right? We had to study with, I don't know, 36 participants, so we needed these Alexas. And now I don't Don't do a study, so I have every room with an Alexa.
You should put each one on a different language setting and have them run concurrently in your home. Oh, that would be fun.
Oh, yeah. My problem is that I often activate the wrong one. So then I say, Alexa, set a timer on something.
You said it doesn't recognize your commands, or is it there's not enough sufficiently interesting applications so that you feel supported in the everyday life? So what's the problem with it?
I think it doesn't understand. I mean, there's not a bit of smartness in this thing. I cannot say all these phrases because it's sitting in the corner, right? And whenever like, ooh, and if you think, if that would be a human being, it would be so super stupid. It's super dysfunctional. It can't do anything. You want to play some piece of music, and it's like, yeah, no, I start the skill for you. And it's like, no, don't start the skill for me. Why are you doing that to me? It's unbelievable.
Often referred to as a natural user interface, right? But and you would think that as it's natural, it adapts to the speech of the user. But really, what we do is we adapt our speech to the device. Because saying something, "Hello, light, please switch on," is not a natural interaction.
And if you don't do it, if you don't adapt, so if you adapt, it works, right? But if you don't adapt, if you're not willing to adapt, and I'm not really willing to adapt to this thing, then it doesn't work.
It's another interface you have to learn.
Hmm?
That's another interface you have to learn as a user.
Yeah. So I think it's not true that these things are particularly natural, and you have to learn how to use them, just as you have to learn how to use your smartphone or whatever device. It might be easier to learn, but I think it's also so limited that might be the reason. I mean, what can you do with an Alexa? What can you do with a smartphone? And there's so much more you can do with a smartphone than with an Alexa, at least in an efficient and effective way. So I wonder why Amazon isn't improving these things. I think it can't be so hard either.
Speaking of Alexa, so okay, it doesn't always work to have intelligent devices because they're not sufficiently intelligent to give us the freedom that we want, right?
I think that's the problem is it works like for a lot of these machine learning things, and including probably Alexa, they work pretty well for, I don't know, a certain percentage. So the accuracy is maybe 99%, but that's, I think, often not enough. I mean, coming back to the keyboard example, right? Imagine you have a hardware keyboard, and the accuracy of your hardware keyboard, that's 98%. How awesome is that? So 98% of the time you hit a key, it actually it recognizes the right character. And that would be terrible, right? I mean, you probably type 100 characters per minute, or I don't know, and then 2 of them will be wrong. And so 98% accuracy is not sufficient for a keyboard, because that's terrible.
And how many papers did I read or review where the accuracy was much lower, like 82, 75? And yeah, so I guess the question is, what constitutes a good model? And that's where these two measures come in, right? There's this notion of precision, where you kind of like, you have the true positives and their relationship to the false positives, right? And so basically what is really a measure to, for example, judge the security of a system, because if you let 1 out of 100 of people log into your account, obviously that's a problem, right? And so maybe you want to optimize for precision, but then there are applications where you want to optimize for recall, right? Where basically the false negatives are matched against your true positives. So basically, is it okay to let certain events slip, right? So if you think of an interactive system, for example, we can quantify the user frustration with a gesture system, right? If I have a lot of false negatives, then basically where the system doesn't recognize my gestures, then that leads to user frustration. So maybe that's where we want to then optimize against. And I feel a lot of these papers, either people discuss only one of them or two of them, but rarely discuss what does it mean for the application to have that kind of metric integrated in them, right? As you said with the typing, do I really want a keyboard where every 10th stroke is not recognized, or even every 100th stroke, right? That means like in a Twitter message, I have at least one spelling error in it.
Well, I mean, for the same application, then there might be cases where this is fine. If you have people that have disabilities, and then providing them with any working keyboard might be like wonderful for them. So then an accuracy of 90% might be like per character, might be like a really big improvement for them. So I think it really depends on the application. And what people do in machine learning is they have these measures that you mentioned, and we use them during training, and they're important, but they're just a proxy for what we actually want to improve. So, and I think typically we want to improve things like the usability, the like efficiency, effectiveness, task completion time, how many errors people make. These are things that we want to improve. And typically, if we train a model, we cannot directly optimize for task completion time, but we optimize for something else, and then we hope that task completion time improves as well. So I think that something that I mean, there are lots of papers, probably not that many of them get published in the end, where people say, oh, we train this model, and then they end with a model, and then they never do a study on that. And I think that is, for a lot of things, not sufficient in HCI. I think you need to study with the model in the end for your typical application.
Because then you would also pick up on some of these problems that you mentioned earlier, that do we as researchers actually know what we're doing? Is this the right model? Did we tweak the model in the correct way, right? If you think about how many papers there are where people kind of throw an SVM and a random forest and all these different types, right, that of machine learning algorithms that come with, like, let's say, a package, standardized package that's XBoost or something, and without really understanding, but then just picking the best one out. Is that sufficiently enough? Can we muddle through when we design these systems?
I think you don't know which one is the best one. That's, I think, your problem. You only have like this poor proxy, which is some kind of accuracy, and you use that, but that's not your final target. And then but you use that to pick a model, but you have to pick a model in some way, right? I mean, what else should you do? And in the end, you want to pick a model in order to do a study to validate if this is actually a good thing. And for the study, you need a model. But I think there are more characteristic things like how stable is that? Does this model enable people to adapt to the model or not? I think if you have a model and it provides, I don't know, whatever accuracy, but people are able to adapt to it because it's stable and has nice properties, then it can be much better than a model that initially provides a higher accuracy but doesn't allow people to adapt to it.
And by adapting, you mean you learning how to formulate your intent so that the system picks up on it.
Yeah.
So basically, adapting your behavior again to the interface or to the.
Yeah. So I mean, for the keyboard, it doesn't make sense for keyboards. But if you have this keyboard and it makes some errors, but you can, if you press the keys in a certain way, then the model, like, it's easier for the model to recognize which characters you want to press. And I think if that would work, then as a user you would learn that, and you might then improve your own performance.
It's interesting, right? Because you need to provide a certain feedback to the user, where the user can actually learn to understand how that prediction model works in order to adapt to it. And that can be subtle or very explicit.
Yeah, and I think like really understanding them, that's super hard, and you probably will not be able to do that for like most recent machine learning models. So if you have like ORACs, this deep neural network, I think that's a problem that there's no way that you actually can understand it.
But you could learn,
But you have intuition about it.
Exactly. You can say, okay, as you said, if I twist my finger by 5 degrees when I try to hit that button, it works much better than when I occlude it, let's say. So we adapt to it. Interesting. So it's kind of like an interplay, it seems, between the advancement in AI or machine learning, and then how does the human fit into that equation, right? And I looked up a little bit of the history of because machine learning is as a discipline is much older than HCI. If you think about
that's debatable.
Is it? Okay.
That can be debated.
You can chime in. So I think in the 50s there were the first kind of like namings of the term AI, right? And then in the 60s there was a famous economist Nobel Prize winner. He says, okay, in the next 20 years we will have solved, or we will have machines that do all the work for all human beings, right? Well, that didn't quite come true, and what followed was kind of like a disappointment, and funding was retracted as a result, and the famous AI winter, or the first AI winter in the late 70s came about. And then in the 80s, we had these expert systems that were massively if-then-else statements, basically, that had a little bit of a comeback in AI. But then the PC came out, right? The personal computing devices. And they really stole a bit of the thunder of that movement and tipped it back in the AI, tipped it back into what was considered, I guess, a second winter almost, because it never really lived up to the expectations that people had. And on the other hand, these machines, or the interfaces, were all of a sudden becoming much more intuitive. So I was wondering if HCI and AI, in a sense, are a bit anti-cyclical to each other. When the AI works really well, there's nothing to do for the human. And when the AI doesn't work well, you'd rather have the human take over. And how do you do that well with a good interface?
Maybe it's just a funding thing. I mean, there's a certain amount of money that government wants to fund stuff, and companies want to fund, they also want to fund stuff, right? Maybe at universities, and then there's a certain amount of money, and I mean, if everything goes to AI, then nothing goes to HCI. But if people at one point realize, oh no, HCI is super important, then nothing can go to AI. I'm not sure if that's true, but maybe that's part of it.
So are you getting funding right now? The AI community getting your funding? Who's on the head and who's in the valley?
I think at the top is clearly AI. I mean, that's, yeah, no question. In Germany,
as a kind of like a unique selling proposition in our research to carve out some of that money maybe and boost the HCI field.
Yeah, I think that's what people try to do. Yeah. I mean, I think maybe also on an individual level, but I think people are trying to like get something from this AI money into HCI, not necessarily for themselves, but for the community. Yeah, but people do that. Yeah. Well, yeah, I mean, because I think there's so much. There are so many open calls for AI professors in Germany at the moment. There is no way that they can fill all of them with qualified people. That's not. There are so many positions, and they need a few more years in order to train people, and then they might be able to fill all these.
As HCI researchers, then retrain ourselves to fit the market needs. So basically, funny, when I started studying in 2004, that was after the dot-com crash, there was always this question, because everyone kind of was hyped by the idea to become an entrepreneur. And so the question was, is it easier to start with business and economics and then transition or pick up the technical skills on the way? Or is it better to start with a technical subject and then pick up the business skills on the way. And so I feel we're on a similar fork right now, where people kind of think about, well, if I want to do science, do I need to study machine learning and AI first? Or can I go straight into something like HCI and hope that I'll figure out how to actually apply machine learning in my applications later on?
No, I still believe that you should study computer science, and then on your, like, while you study computer science, you want to pick up HCI and you want to pick up machine learning, and then you go for whatever direction you like. I think in the future, so I'm pretty certain that that already happens, that there will be, in your bachelor, there's one lecture on introduction to machine learning, just as there used to be a lecture on introduction to databases. And would assume that not every university has an introduction to databases, and probably only few still have an introduction to compilers and how to build compilers. So these, I mean, the curriculum that changes all the, slowly, but all the time. And I would assume if you don't have machine learning courses in your bachelor program by now, you will have that in everywhere. But I think then, do we need, if you study something completely different, like biology, do you have to take a machine learning course? I think you probably should take a programming course first, right? And then you can also do machine learning for biology.
And MIT does that, right? They request everyone, no matter whether you're in the humanities or different subjects, they request them to take at least one programming or computer science class.
Yeah, and I think that makes so much sense. And like, I'm biased, clearly I'm a computer scientist, so I think that's the way to go. But yeah, I mean, it's certainly helpful, because if you want to do a bona fide PhD in biology, I can't really imagine that there are still things where you don't have to be able to program at least a bit. I mean, maybe not Java, maybe not Python, but something like R or something like that.
And then coming back to machine learning, how much of that do you need to understand in order to be able to intelligently use those tools, right? So if you think, for example, on libraries such as the OpenPose framework, for example, right? This camera-based detection of, the body torso and movements, limbs and interaction gestures and such. That's a really powerful framework that I don't need to necessarily understand how the underlying recognition works, but I can use it for building engaging applications where people jump in front of the camera, right? And also more useful, or like more use case driven applications, such as, count the number of people at my inauguration, right? So we could use those kind of things, and without necessarily having to dive deep into, how many epochs did you use to train this model? So it'll become a tool, I think, also that everyone can just have on their belt and pull out when the situation is right. And we need to teach people how to recognize those situations, and like checking a couple of boxes, say, okay, is this feasible? Is this doable? Does it make sense? And then also, obviously, is it an ethical thing to do if we think about what are we actually doing to our users or to our society by using these kind of tools in certain contexts?
Yeah, and I think that's similar to I don't know, databases, right? I never built a database, in like an actual database, something like an Oracle system. And I would probably not be able to do that, but I still use them, and I took databases courses. So I think that's the same for machine learning. I mean, you don't have to be able to build, you probably are able to build a neural network from scratch, from nothing, right? I mean, if you're a computer scientist, it's not that hard. You can do that. And you can also build a basic database, but you don't. I mean, for both of these things, there are much better tools out there, and you just apply them. And having an idea about how it works, being able to, in theory, implement it from scratch, I think these are good things. But that doesn't mean that you should implement it from scratch at any time.
Wow. So on a practical note, where do people publish this kind of work if they combine HCI and machine learning? What are the venues we should be looking out for?
I think the most obvious one would be IUI. I was there only last year, so the only time I've ever been there.
Intelligent user interfaces.
Intelligent user interfaces. I wasn't too impressed, but I think it was not what I expected, at least. I expected much more technical work. There was more on the softer end of things. That was my impression. Things like explainable AI, but then I think you can approach that from a very technical point of view, but you can also approach that from a very user-centered perspective. But then I think there's a disconnect to what's technically feasible. Yeah, so I expected something different. But I think certainly intelligent user interface would be something. But then I think the typical HCI conferences as well, things like Kai or mobile HCI, if you look at mobile devices. I think if you look at like the machine learning conferences, you will probably not find anything about HCI. Like that we would consider human-computer interaction.
There's this notion of human in the loop, right? Have you heard of that?
Yeah, I think people use that in different ways. So what's your understanding of human in the loop training?
Yeah, so I would, I've seen it in the context of, if the algorithm breaks down, what do we do? We'll pass the control back to the user.
Mm-hmm.
Right? Or we use the actual human to do a proper labeling. Let's say I can say cat, dog, cat, dog, cat, dog, and then there's a couple of kind of huskies or cat dogs, dog cats in between, and I don't really know, and so I need a human to kind of like pull those P2 apart. And say, okay, that's the correct label. And I think that's quite relevant when we think about safety critical applications such as self-autonomous driving. Right? And where most of like 80% of the cases, probably or more, can be covered by the AI, like driving on a highway, for example, doing a lane change. But then all of a sudden, the weather conditions change, there's a construction on the road, and all of a sudden the AI might start struggling making sense of these conditions and somehow alert the user to pull them back into the interaction, say, okay, hey, better stop whatever you're doing, watching that Netflix show, come climb in the driver's seat and take over. Right? And I think that's one of the HCI challenges, how to do that and how to bring in the human in a effective way. That's how I see it. I don't know.
Yeah, I think you're most probably right. When I saw you work on like papers with human in the loop in the title, I was super excited because I expected something else. I expected approaches where you train this machine learning thing. You have to train the model, but you train it in a system. So you say, oh, this is my box, this is my system, and inside this box is the machine learning model and the person. And now I want to optimize the system, right, including the person and my model, and then I train, and then the model learns because it's a machine learning model. It can learn, but the human also learns, right? Because we're humans, we also learn. And I expected things like that, where you train a model and a human, and you train them at the same time. So that's what I expected. But it was more. I think there's more. There's one more thing that's also called human in the loop, which is
the reinforcement thing that we were describing.
Yeah. I think there's the other thing that's also called human in the loop, that is during training. So you have a machine, you have an expert, and you have the model, but you have so little data, or you want to, for whatever reasons, the expert can push the model into certain directions. Can say, oh no, this is really bad, or this makes a lot of sense. That's then human in the loop training, I think.
Well, a malicious actor, right, can compromise the model when it's being trained.
So
This actor could compromise the model while it's during its training.
yeah, probably.
There's this story of I don't know if it's true, but apparently somewhere in South America there was a U.S. military base, and they were not exactly wanted there, and they had a couple of motion sensors around the perimeter, and when the people who didn't want the U.S. there basically figured, okay, whenever there's lightning out there, we'll go and trigger those motion sensors. And so the first time they went during a night of lightning and triggered the motion sensors, and then the entire base camp went wild, alarm, and came out and looked around. Obviously, they were the attackers were hidden, and so they came back right the next night when it was lightning out, and again, kind of like triggered those motion sensors. Then the alarm went off again, and at some point the GIs kind of like figured, oh, there must be a faulty system, because every time there's lightning, making this presumptions, right? We'll go out and there's no one there, so it's a false alarm. And so one night there was lightning, no one came out, and they attacked the base. And I think there's a name for this in cybersecurity, where you basically compromise. And I'm not a cybersecurity expert, but I heard that in that story in one of their presentations. I was fascinated by the fact that you can build in backdoors into machine learning algorithms by interfering with the training of the model.
That makes a lot of sense. Yeah, I haven't thought about that, but that's cool. Yeah, I mean, probably something we should consider when we use these systems, or use them as a library. But maybe it can also be used for HCI. Can you think about something? So the system works just as expected most of the time, but then there's a backdoor. Could you envision a use case for HCI?
I think one of the big problems, right, when we train models is that we don't always have a balanced data set. So if you think about a classification algorithm, let's say, emotional, right? You have 5 different emotions, but then there are really few instances that you can collect where people are, for example, surprised or fear or experience fear, right? But there are a lot of instances where you can say, okay, that person is really happy or is really sad or neutral. And so what happens is that due to the unbalanced data set, it's really hard to pick up on these, like say, episodes of surprise and fear, right? And so we need to kind of like give them a way of compensating for this lack of data. If you think about situations where you do want to give extra attention, let's say if someone is sad and gets surprised, right? Because that might worsen their situation, for example. And rather than not recognizing it because it's not as likely to be picked up by your model, but rather than say, okay, even if we don't recognize that case that easily, we need to, when we build this model, we need to make sure that we bias the training towards cases that can be quite detrimental if we get them wrong.
Yeah, that makes sense. So to not only optimize for the individual classes, so that you have don't treat all classes equal, because there are some classes that might have severe negative effects on people. I think you're hitting the 60 minutes mark soon. If you think about that, so I think you're quite successful, right? You in HCI, but you also look into machine learning. If I'm now a student and would start with that, what should I do? If I want to think, oh yeah, HCI is fascinating, but I really believe in artificial intelligence. So, and now I want to dive deeper into that. What would be your recommendation?
I just recently took another class in machine learning on edX, for example. Stanford has a bunch of them out there, and they're really good to dive into the topic, but also keep up with it. I was talking to an entrepreneur from Brisbane the other day, and they're running an AI company, and he said the moment he interviews a programmer, and they are able to take a contemporary paper, an AI paper, and turn that into code within 48 hours, they were going to hire them. Well, that's quite a hard challenge, right? But that's basically because the field evolves so quickly. The tools that we get, like TensorFlow, they make our lives easier, but they require us to constantly learn. And so what I would recommend students is to look out for this field and try to keep up, try to understand what's happening and how you can make use of the tools that you're given. 1 second, which is fine because it's a Friday night. Application, curious applications of machine learning. You know, we talked about typing input, gesture recognition, detection models of different.
All the serious stuff, right?
Yeah, all the serious stuff, right? But if you look actually what's coming out almost on a monthly, weekly basis, it's quite amazing. In open access journals, you gotta love them. They document a lot of that. And I do remember, so for example, a couple of years back, you were playing with a model to swap faces.
Yeah.
Remember that?
Yeah, but that, yeah, they have these deepfake stuff now.
Yeah, there's face shifter, right? Where you can just like put another face on someone else's body and stuff like that. I thought that was really funny and interesting. But then there's this other things. I'm just gonna share my screen real quick. Because I think Stefan Schneegass was doing something similar for authentication, only this one is different. So Stefan used sounds, right? He would play sounds through the head, through bone, and then pick up with a microphone how much of that sound is absorbed. And from that, he was able to create unique signatures to identify the user who's wearing the device, which I thought was really cool.
Yeah, they have now an entire project on that. So, like, not only for this thing, but also for like using the human body, I think, as a filter function.
Oh yeah, okay. So this paper, it's almost a challenge. So this is the unconstrained ear recognition challenge, and this was last year. And the challenge was basically, we have ears from different angles, with different rotations, and different times of lighting conditions. And can we use that to identify people on a unique basis? And so it was an image recognition challenge, because apparently our ears are quite uniquely shaped. And I think it's a hilarious or really also useful example of using machine learning. If you think about whenever you pick up a call and you put it to your ear, you know, the front-facing camera could just make sure that whoever you want to talk to on the other end is that person. And I think that challenge.
Yeah.
Really good.
There was, I think it was Christian Holz, they looked into, you do it like this, so you hold your phone to your ear, then there's the capacitive sensor, and that recognizes then this is actually your ear.
Right. Yeah, I remember that paper. They hacked the touchscreen.
Yeah.
There's a second one, in case you're interested, how the world looks like in the reflection of a bag of chips.
Ah.
And like this notion of, you know, everyone always talks about taking different perspectives on the world and such. And I think these guys took it to another level. So what would it be like if we looked at the world through a bag of chips, which I really, really liked.
Why are they doing that? What's their motivation?
Well, you could always argue it's a piece of art and contemplation. Or we do it because we can. Or maybe you have some ideas for a clever application in the HCI field.
No, I mean, you want to have the opposite. I mean, you see the world through a bag of chips, and then you want to reconstruct the world, don't you?
Oh, that would be a spy application.
Yeah, and I think people do that. It doesn't really work that well.
I think it's empathy creating kind of applications. And here comes my favorite. So this is a paper that talks about teaching AI how to create humorous scenes. And so, so, you know, everyone always talks, oh, artificial intelligence. It's not really intelligent because it lacks either the emotional understanding or the creative spark or humor and love and all these things, right? And these guys here and gals, they wrote this paper about we are humor beings, and they trained an AI to recognize scenes when they're unfunny and turn them into funny scenes. So here's the outcome, basically. You can see this is what's considered a funny scene.
No.
Raccoons that are drunk at a picnic, or dogs that feast while the girl sits in a pet bed. Also, what the AI considers funny is rats that steal the food while the cats are asleep. But then the AI can turn that scene into an unfunny scene, and it does that by replacing the rats with more food. So the food is carried away by other food, and it thinks that that's not funny. And we talked about ground truth collection, right? And so the authors here, what they did is they basically they showed different scenes and different objects and different combinations to MTurk workers, Amazon Turk workers, and had them rate basically the funniness of the scene. So here on the left you see a lady walking her dog, which is not considered not as funny as, for example, dogs having what looks like tea in a bone. But even funnier than that is a guy drunk in the park, and even funnier than that is a woman being consternated by the fact that the cat is surrounded by mice. And so this is kind of like the ground truth that they had, and they broke it down into different scenes and different objects that are present in the scenes, and then they fed the algorithm different types of scenes. So let's start with the funny scene, and then it asked the AI to turn the funny scene into a non-funny scene. And so the funny scene here is a bird stealing the steak while grandpa is kind of getting upset. And to make that not funny, the AI replaced the grandpa with a boy that throws a ball and just removed the bird. And this one is quite bitter.
No.
So watermelon, which is apparently the funny one, which gets replaced with an axe. And so, and then they gave it like unfunny scenes and told the AI make this funny. And so here it replaces basically this dinner of this couple into a dinner with what looks like cats, or this pretty low-key park scene, which is amplified by having a raccoon ride on a scooter.
Obviously, yeah.
So fascinating paper. Whoever said that AI cannot be funny is now officially proven wrong. I think that's a great use of machine learning, which we should definitely look at as we're creating our interfaces and add a bit of spark of humor to them.
Cool. Yeah, that was interesting.
What's the funniest application you've seen last?
I think I don't see funny applications. I'm only on the serious end of things.
All work, no play.
All work, no play. And what you see is scary or uncanny things. If you look at all this face stuff, there was this stuff from NVIDIA, they generated faces, and they're pretty good nowadays. But sometimes they're not, and then it looks really, really, really strange. So you see this human face, and it's almost perfect, and it turns into something so disgusting because they make some tiny mistakes. So I think that is kind of interesting. It's not funny; it's more disgusting.
Do you think that's the stage of the deepfakes right now? Have they crossed the uncanny valley yet?
Yeah, I think so. If you look at the very good ones, it looks extremely. I mean, for certain domains, of course, but for these face generators, they just generate random faces. I think, like, if you look at the most recent ones, it's undistinguishable from photos, I think. I mean, not all of them, but I don't know. I think if you would have human raters, they're probably still better than chance, but not by that much.
That's somewhere already. Can I give a Niels Henze lecture here in Melbourne?
I think that's the different thing, right? I don't know. I think all the components are there, but it's not really usable. I have a student project. They should do that for me. So we're recording these lectures at this moment, and it's quite some work. And my hope is that the students they'll build something that gives them a picture of me, a slide deck, and like then an audio track, and then they generate a lecture for me with me in the video with slides and stuff. That's their task. I don't know if that will work out. But I think the individual pieces that are there, you just have to combine them.
Think about the time we could save by just downloading your lectures and then putting my face, putting Albert, and we would have much, all the quality of Niels Henze, but the visual expectation of Tillman.
Yeah.
All the time that frees up all of a sudden.
Yeah.
Can we have that? Because then I wouldn't have to dress up like you, right? I mean, right now I'm in my pajamas, as everyone actually is. You look quite fancy. But I'm in quarantine mode here. If I could use deep fakes, I would not need to get out of that mode. I could just use pajamas to record my lecture and then change the exterior accordingly.
Yeah, totally. But I think at one point you might have to go back to class.
Who knows?
But I think what you could also do, like, imagine you give an introduction to HCI. You can you take our audio track, then you generate a Tillman talking to it. There are models for that. Then you have to change the audio, so you have to transfer our audio track into like your voice, and there are networks for that. But in between, you probably want to translate it anyway. Yeah, that makes sense. So you take the audio track, you have to translate it to English because we talk German. And yeah, I think that you can build such a system nowadays that turns our German lecture into your English one. I think it will just not work very well, but there will be an output.
We should try that out. Where are these guys based? Somewhere in California, right?
Who?
The Obama video that they published. Or was it CMU?
No, I think there are different groups doing that. There are also German groups doing that. So yeah, I think. And like the Obama video, I think that's often used by different people, but there are multiple groups doing this kind of work. And I'm not sure how much source code is out there. So typically these machine learning people, they publish their source code. But I think Google didn't do that for their recent text generator because they were concerned about it.
Was that Google? The GPT-2, right? Is what you're talking about.
Yeah.
Release this step by step so that we can have enough time to find countermeasures to identify these fake texts.
Yeah, and I'm not sure what these deep fake people do, but I mean the papers are out, so I would be certain that there are re-implementations.
Yeah.
Of some of the papers.
Taking student lectures. That's the next level. Because then I could also give violin lectures. I think in Germany, right, you are able, because you're a professor and you have a PhD, you are able to teach anything in theory.
No, I'm not able to do it, but I'm allowed to do it. I technically I'm allowed to teach anything I like, but there is some. We discussed that in Stuttgart when I was in Stuttgart, and technically I'm allowed. So I can give a course on, I don't know, physics, whatever, right? Advanced quantum physics. But the physics people, they don't have to accept my lecture for their course program.
Ah, okay.
So that's the catch. So a student could take my lecture, but it wouldn't happen for their degree.
You know, there are all these learning analytics studies out there, right? What helps people really learn? And if they found there's this one generic face, or this one generic voice, or this one generic appearance, right, that helps students completely focus, then you could just replicate it across all disciplines, across all lectures, and have that appearance teach basically everything.
That sounds like dystopian. It could be that each university has their own lecturer, right? If this is Regensburg's lecture, and all courses in Regensburg are given by that same person. That sounds really, really terrible.
You still have your experts giving the lecture, right? But you replace their exterior.
Yeah.
With whatever works best for the students.
Yeah.
So either, Niels, you become the face of the nation, or you become a gray face.
Yeah, I think people appreciate that they can connect certain lectures to certain people. I think that's really helpful, because then you're sitting in the lecture hall and then you see that guy and then, yes, that is HCI. I think that.
Oh my God, international subject branding. I think we're onto something here.
Cool. So thank you, Tilman. That was very interesting.
I hope you have a fun Friday.
Yeah. Have a fun Friday night, I would say. Cool. So thank you.